During this session I'm going to introduce the different types of wind turbines, consider how you can calculate the energy transformations involved in some types of wind turbines, and also consider the benefits and also negative impacts associated with wind turbine power. So let's start off with, I guess, the types of wind turbine. The one that you're probably most familiar with is something which looks a lot like this. There's a propeller blade and the wind causes it to spin around, and at the back there's a gearbox and a generator, so the rotation of the blades causes the rotation required inside a generator for the production of electricity. This is known as a horizontal axis wind turbine, or HAWT. Now there's certain features of a HAWT which makes it both positive and negative, I guess the advantages and disadvantages. First of all, the advantages of a HAWT system. The variable blade pitch gives the turbine blades an optimum angle of attack. Okay, so it means that you can move these things around, so therefore they can always get the most energy from the wind which is approaching. Tall towers also allow the bases, or tall towers allow us to reach much stronger winds at an increased elevation. Disadvantages are that when we're close to ground levels, the inconsistency in turbulent winds means that these devices don't work quite as effectively. This means that you have to create very tall towers and have particularly long blades, and this makes it very difficult to transport these in the first place to whatever location they're being set up as. Tall HAWTs are difficult to install, so therefore it's, to make it so tall, it means the cranes are expensive and the operators need to be very, very skilled. In turn, this massive tower construction is required to support very heavy blades and a gearbox and a generator at the top, so the construction of the tower becomes very challenging in itself. There's reflections from tall HAWTs often affect radar coverage in the area, so there's people who are using radar and people who are flying often think this is an intrusion. Some people feel that they, because they're visible across large areas, that they're a blot on the landscape. I personally think they're just an incredible sight to see, especially when in large numbers across a hillside. Finally, because they need an additional yaw control, so to turn the blades, it means that there's an additional feature which can break down in some way. So there is another type of turbine, wind power turbine, which is, I guess, people are less familiar with. This is a vertical axis wind turbine, sometimes known as a VAWT. So what happens with a VAWT? The disadvantages are wind speeds. This is set up at a very low level. Okay, so there's not the high tower, and actually wind speeds tend to be much lower, closer to ground level. Therefore, the overall efficiency is not that impressive. The machine is not self-starting, so it means you've got to give it a push to get it going. Okay, once it's going, as long as there's a wind, then it will keep on going quite happily. But if it grinds down to a halt, you need to give it a push again to get started. The machine often needs guide wires. These guide wires can stretch over very, very large areas just to keep it in place. Once the bearings go on this, it's really, really difficult to replace. If anything goes wrong, it's a real pain to replace these things. There are some advantages though. It can run close to ground and does not need to change direction anyway, so it can accept wind from any direction we have. So that's the vertical axis wind turbine. As it happens, the thinking or the calculations which you're going to have to do are always going to be related to a HAWT system. So to get the maximum power output, what I'm going to do is I'm going to help derive the formula which the IB Physics datasheet gives you. So first of all, we think about the area swept by the blade. So if we think of the length of the blade, and that's going to be pi r squared, gives me the total area which wind enters the blades. We think about the wind speed, so the wind speed has a big impact, and we think of that as the distance travelled per period of time. That means in 1 second the volume of air passing is the velocity times the area. So therefore, building up on this, the mass of air passing through the turbine in 1 second would be the density of the air times the velocity times that total area. So kinetic energy available each second is going to be half mv squared. We know that the mass is going to be density times the velocity times area times v squared, which gives me half density area v cubed. And therefore the maximum power output is, remember, because we're thinking about crucially the amount of mass which is passing per second, so this all becomes very quickly half density times area times v cubed actually gives me the amount of energy transferred per second. So that's the maximum power output. So that's a formula going to be required to use at some stage. So to give you a chance to use this, here's my wind power question. Here's the statement. A wind turbine of blade length 54 meters is operated at a wind speed of 10 meters per second. The density of the air is 1.2 kilograms per meter cubed. This is the information you'd have to be given. How much power is in the wind passing through? Give you a moment to do that calculation. Press pause. How much electricity power is generated if the turbine is 20% efficient? I'll give you a moment to calculate that. Press pause. The fast question is, if the wind increased to 15 meters per second, how much power will be produced? So, using your understanding, you should be able to solve these problems. 5.5 megawatts is the amount of power produced. 1.1 megawatts is the amount of electricity produced if it's only 20% efficient. And if the wind is increased to 15 meters per second, how much power would be produced? We'd get 3.7 megawatts of additional power. So with that, look at the general features. So this is more likely what you're going to be talking about in an exam. The general advantages of wind power: it's renewable, there's no chemical products, it's cheap to run once it's built, there's no global warming because there's no CO2 emissions associated with this. A disadvantage is unreliable because of the wind. Few areas are suitable, so they have a constant flow of strong wind and not to be in a place to disturb, I guess, a major population. A low power energy source, the amount of power produced is actually quite low relatively. Some people see these things as noisy and unsightly. They're very expensive to build, and a large area is required, particularly if you're talking about creating an absolute wind farm. And finally, there's some features which is thought to be kill migratory birds, although there's not that much evidence for that. Okay, so that gives you an overview of how wind power could be a solution for replacing fossil fuels in the future.